Hello, IPXers, those looking for disruptive technology, headphones, spatial audio. If ever there's some alien technology around, spatial audio I think is just what we're talking about. And we're here to talk about Seth from CEVA. I'm going to take the headphones off now so I can hear what he's saying. But he's going to tell us all about the world of spatial audio, how it works, why it's important, and why you should be thinking about it in your next application. So Seth's got this marvellous little story about a Stephen King movie. He's going to explain how... You didn't know I was going to do that, did you?
I did not.
Exactly, which is great. Tell me about the Stephen King movie and where the whole idea, now I can hear you, now I take the headphones off, how spatial audio came about and then how it ends up being in those.
Yeah. So spatial audio, the idea behind spatial audio, if you're wearing a pair of headphones, the audio comes from these two speakers.
Yep.
Right? Which are sitting right by your ear.
Yep.
Right? So you hear the sound right by your ear, and in fact, if you're trying to listen to a movie, let's say, where they've mixed it so that the dialogue comes from the center, your brain actually interprets that as coming from inside your head. So the goal of spatial audio is to make you forget that you're wearing headphones, to pull that audio outside your head and into the real world.
Yep.
And that's done with software algorithms. So spatial audio is a psychoacoustic effect, which means we're tricking your brain into hearing sounds that are actually coming from here, that's coming from outside your head. So it's been around for decades, and one of the early attempts, that at least the earliest that I remember personally, was an audio book that Stephen King recorded called The Mist.
Yep. And
what he did was they took a foam head, like a mannequin dummy, put microphones on it, and then performed in the round around this head so that you would hear the recordings. So it wasn't technically spatial audio.
No.
But the idea, again, is to how can I recreate the sounds of the real world with just these two speakers?
Yeah. So just to be clear, it was a silly example of mine, but Stephen King thought if you're listening to an audiobook, he wanted the idea that you'd hear, without this kind of technology, you'd hear the actors coming from different places so that your ear would understand that they were talking in different places.
Exactly.
And that was actually incredibly innovative at the time.
It was incredible.
Very, very clever.
Incredible. And it was a lot of fun to listen to.
Absolutely.
It was scary as heck.
Exactly. So now, using your technology, you can now get that effect with these.
Exactly.
So explain the benefit to the benefit and how that works.
Yeah. So again, it's all about making you forget you're wearing headphones and hearing the sounds in the real world. So think about playing a game, right? You're in a shooter game, enemies creeping up behind you, right? If I'm wearing headphones, I hear, okay, there's someone somewhere vaguely behind me. Now imagine being able to pinpoint exactly where they're coming from.
So your eyes are seeing something, your eyes are seeing the game in front of you, but using your technology, you're able to make that experience and trick the brain thinking there's actually someone coming up behind me, which enhances the whole experience of how that game works. And that's all because of this these many years of algorithms that you've built up that enable that to happen. This can't happen by accident, is the point.
No, absolutely.
You can't just turn up one day and go, I'm gonna create this. You have to have understood how you got there, step by step by step by step.
Exactly. So there's two major components to this. There's the spatial rendering, which takes the content that comes in as, could be stereo, could be multi-channel, and turns that into this spatial effect. And then there's the head tracking, where you're using an IMU in 90% of the cases. Some people are experimenting with some new technologies, but you take an IMU to track the motion of the head, and that lets you fix the sound in space, no matter how your head is moving.
Yeah.
Right. And to make a good spatial audio system is not that complex. On the rendering side, you need to deal with reverberations, you need to deal with reflections, and you need to deal with what's called the head-related transfer function, which is basically a mapping of the shape of your head, ears, and shoulders to know how those reflections are going to hit you.
Right.
So to make a good system is easy. To make a great system is really, really hard.
Yeah.
And takes a lot of experience, a lot of know-how,
There's a lot of nuance and
A lot
subtlety
of
in there.
nuance, subtlety. There's a lot of edge cases you have to deal with.
Yeah.
There's a lot of different effects you have to deal with, and you know, one of the interesting things about spatial audio with this HRTF, everybody's head is different. Everybody's going to have a different HRTF. So if I've got a system and I pick an HRTF and that's my default that I work with, it's going to work really great for some people. It's going to work not at all for others, right? And so how you solve for that, how you find a way to make it so that everybody gets a good spatial experience is a pretty difficult, unsolved problem right now.
Right. So if we take the example, that wonderful, beautiful, anecdotal example of Stephen King creating an in the round, you're now able to create that using these headphones. So potentially what you're looking at, that's where you hear from the sound coming from, or if you're hearing it from the back, that's where you hear it from. And what you're explaining is that actually that's a really subtle and nuanced environment. Anybody could do it, but to do it really, really well, you need the experience and the knowledge of 20 years of being in the game of building algorithms.
Yeah, absolutely, absolutely. And you know, the example of the sound coming from where you expect it is actually really key. One of the things that we all experienced during the pandemic was Zoom fatigue.
Yeah.
Right. And you know, we just got done with so many Zoom video calls. And a large part of that is because the brain is working really, really hard because the voices aren't matching the location of the faces.
Yeah.
Right? Everything's coming from this one
And that
point.
is truly nuanced because you're looking at a screen, but you might have 8 faces.
Yep. And it's not like they're that far apart, right?
No,
The screen
exactly.
isn't that big. But even that subtle difference is hard work to reconcile for the brain. And so you can imagine, right, the advantage of spatial audio that now, you know, this is a little bit futuristic, but you know, we're not that far from it, where the voices are going to match where the faces come from, right? No matter what, you know, and those things are changing all the time. Someone joins a meeting, leaves a meeting, and everything shifts around, right? And now it's so much easier. And you'll find that when you wear a headset with spatial audio, whether you're taking Zoom calls, whether you're listening to music, watching movies, right? That fatigue is gone, and you can wear them all day. Whereas, you know, people don't even realize how tired they get, even just watching movies with a standard headset.
So let's just review that for a moment, because that's quite interesting. Because what you're saying is that with something like spatial audio, even if you do good spatial audio, you are eroding the calorific burn on your brain, because that's essentially what you've said.
Absolutely,
that's essentially what you've said. You know, and you know, if I'm a movie maker, or if I'm a game maker, or if I'm expecting, you know, my consumer devices to keep the attention, you know, are going to be loyal to a particular platform, you're going to be on Zoom all day. That is eroding away calorific burn in your brain. But if you do it excellently, that can make that burn last longer, because the brain is working less in that interaction.
Imagine a gamer who's streaming their game on Twitch for hours and hours at a time. Yeah. Right? Imagine having that energy that you had been spending on reconciling this mismatch to use on your game. Yeah. And the advantage that that's going to give you over the long term.
Yeah. We're going to a whole different social discussion there, but anyway, yeah, I understand your point. Loyalty to games is going to go higher the longer you can concentrate on them, and the more you can expand on them. Okay, so we talked about the context of this spatial audio. Very interesting background. We've gone back to Stephen King, and then we've gone through the whole thing about understanding in the gaming environment, how you can hear footsteps coming from the background. And then we've gone to the real practical world of how that can benefit with things like Zoom calls, where you can actually see that if one particular person is talking, your brain is being conned, for want of a better word, to see that they're talking, but of course the source is coming from the same place. Yep. So that's the context of this. Just talk us through very quickly the practicalities for a design engineer who says, excellent spatial audio is for me, that's what I need. So what are the practicalities if I'm going to say, I want to understand that? Just talk us through briefly what the practicalities are of how you start that journey, and then how they'd come and talk to you about how you can help them do that.
So there's lots of different ways to do spatial audio. So the first questions you need to ask yourself is, well, what are the device that I want to put this on, and what are the use cases I want to support? So if you want to put spatial audio entirely embedded on a headset, you can do that, right? And that's what this headset does. It's got the spatial renderer, it's got the head tracking, and what that means is I can take any content and render it spatially.
Right.
But there are trade-offs, right? Because it's Bluetooth, you're only getting 2 channels of audio across, right? I can also choose to render on the headset, on the host, right? Could be on the phone, could be on a PC, on a console, on a dongle, right? And then I do the rendering there, and so now I have more processing power, so I can be a little bit more clever in some of the things I do with the reflections and the reverberations.
Yeah.
And I can render that multi-channel content, right? And then send that across. So now I get the experience is a little bit more like what the original audio engineer wanted it to sound like.
Yeah.
The trade-off there is latency, right? So it really is going to depend on what your use case is, what you're looking to optimize for, right? And then we can help walk you through that, right?
Yeah.
And you know, you can do both, right? Maybe I'm making a full system, and when I'm paired with my host, let's say I'm a mobile phone OEM, right? And I make a pair of TWS, right? Well, when my phone is paired with my TWS, I want that to be the best experience.
Yeah.
But that doesn't mean I want my users to have a lesser experience if they're listening to their TV, for example.
Right.
So we can have the spatial renderer in both places, right? And then there's subtleties of well, when do I do the rendering on one side and the other, and how can I reduce the latency of the head tracking and so forth.
So what you're suggesting there is, in some ways, there might be some predefined ideas about how this will work, and you're saying actually there are subtleties and there are different ways of doing this, whether you do it on the host or whether you do it on the end headset. So don't have any predefined ideas that this is definitely the way you have to do it. You need to come and talk to you, and then you'll work through those subtleties with them to work out what the best solution is.
Exactly. We have multiple different architectures, multiple different solutions for spatial audio, and we will absolutely help you figure out what the right answer is.
So one final question. How obviously with this you're buying software. Mm-hmm. Tell us just a little bit about the sort of agnostic ecosystem of silicon that you work with and you have experience of, so that people can feel very comfortable, how that actually works in terms of sitting on the silicon.
Yeah, so these two pieces, the spatial renderer and the head tracker, can run on just about anything. They can both run on the same DSP. You can run the head tracking on an MCU. We've even run scaled down versions of the renderer on a low-powered MCU. Right. They can run on, in some cases they run on a CPU. If they're running on the host, they run on the application processor on the phone. Right. So it's very flexible. The IMU for the head tracking system, right? Our motion engine software runs on. We support sensors from all the major manufacturers. It's sensor agnostic.
Right.
And again, there's trade-offs there that we have decades of experience working with. So even selecting your sensor, right? We can help walk you through that so that you're getting the most cost-effective thing you want that still gives you that excellent experience you're looking for.
Yeah, I understand. Okay, I think that's an amazing introduction, where we've gone through the whole gamut from where we started with a silly idea well, not a silly idea, a brilliant idea from Stephen King, going through how you make real life experience with a gaming environment using this kind of technology, and then how you can keep people listening to Teams meetings for much longer than they might have done. And then we've just then finished with just explaining that whichever platform is your platform, or whichever way at the moment you do it, whether it's with a host or with a headset, and whichever kind of platform you're using with silicon, you're CEVA completely comfortable with working around that, understanding the nuance, and then giving you the right kind of solution.
Absolutely.
Good. There we go. Thank you very much for that introduction. This is how this works. This is how you're going to get not just good, but excellent Good's relatively easy, apparently. Excellent. There's only one place. Thank you very much. Thank you, Seth.
Thank you.
Very good.